Hello everyone, welcome back. Today we are going to talk about styli. They are important components used to measure all sorts of materials and parts, and we need to know the type of styli that is adequate to use for our application. A stylus is constructed from three components: the adapter, the shaft, and the stylus tip. Usually, when we look on different sites that sell stylus systems, we will see something like this. Every component from the stylus system is identified and the dimensions are marked so that you can choose the correct configuration suited for your needs. Companies like Hexagon and Renishaw typically uses shafts that are based on an M2 to M6 threading, and companies like Zeiss uses M3 to M5 threads, depending on the type of measuring head used. Different types of materials are used to construct the shaft of the styluses, like steel, tungsten carbide, ceramic, and carbon fiber. And if we have a look at their specifications, we will find out that the differences matter. For instance, tungsten carbide shafts are heavy, do not have much deflection when touching a surface, which is good, but we have a high thermal change, meaning that when the shaft is longer, the thermal expansion suffers. But it's great for measuring short lengths or for measuring small surfaces due to its capacity to hold styli from up to 0.12 millimeters. Carbon fiber shafts have less weight, is better at deflection than tungsten carbide shafts, and has non-thermal length change. The only disadvantages for these shafts is that it can hold styli up from 2 mm and no less. Stainless steel shafts are frequently utilized for styli with ball and tip diameter of 2 mm or more and lengths up to 30 mm. With sufficient ball to shaft clearance and without sacrificing overall deflection, we can add a junction between the shaft and the thread. Although one-piece shafts provide the best weight to deflection ratio within this range. Ceramic shafts are utilized with ball diameter from 3 mm. They are great with thermal expansion, like carbon fiber shafts. They have great deflection comparable to steel, but lighter in weight than tungsten carbide. And the best part is that if a collision occurs, the shaft will be shattered, but no damage will be taken from the measuring head. It is recommended that styli longer than 40 mm to be constructed with ceramic or carbon fiber shafts due to their low weight and non-thermal expansion properties. Now, if we move down to the stylus tips, the most commonly used tips are the spherical ones. For precise measurements, the ball sphericity and the shaft's rigidity are essential. The tip can be made of materials like ruby, diamond, silicon nitride, ceramic, and even tungsten carbide, and can be used to measure all common tasks such as diameters of holes and shafts, depths, surfaces, and so on. Cylindrical styluses have two types of tips: the cylindrical tip with spherical head only made from ruby material, and the one with the flat surface at the end of the tip made from materials like steel, tungsten carbide, and ruby. This types of styluses are used to measure edges and are commonly used when measuring sheet metal. Hemispherical tips are used in applications where big holes and cylinders are needed to be measured. The spheres are cut in half and some are even removed to the weight of the probe's limit values. Hemispherical tips are typically made from ceramic material. Disc styluses tips are made from materials like steel, tungsten carbide, and ruby. They are typically used to measure undercuts, locate deep grooves, and measure inside and outside of cylinders or holes. And the last one from our list are the styluses with conical tips. Made from tungsten carbide, they are used for self-centering probings and scanning with low accuracy. They should not be used for conventional XY probing. When it comes to materials used to construct the styli, ruby is the most cost-effective option and has exceptional hardness and wear resistance. Silicon nitride has a very smooth surface that provides less friction when scanning and does not accumulate material as ruby does, particularly when scanning aluminium. Ceramic material used to make the styluses tips are also durable and good for measuring casts and steel parts. And diamond is the most durable material used to make the stylus tip. But it's also very expensive, the most accessible one being the diamond coated. It's ideal to measure aluminium parts because it will not accumulate material on the surface. But how do we know when a stylus is not working as it is supposed to? Well, the calibration will show us this. Every anomaly in the calibration above or below the standards recommended by the manufacturer can show us that something is wrong either with the measuring head or with the styli. And the main reason for the problems with the stylus tips are the material buildups, wear of material from the surface, and cracks on the surface of the shaft and on the stylus tip. All of these defects are small and cannot be seen by the human eye. Special equipment like a microscope have to be used to determine the type of the defect. Or you simply just change the stylus with a new one. There are a lot of tips all over the internet for good practices when you use styluses, but we will mention only the most important ones. So the first tip is to use only genuine stylus recommended by the supplier of your measuring device. Do not try to reproduce stylus systems. They are done with precise machining and have quite important components, and they do have quality components. Keep in mind the ambiental conditions where you work. This is the second tip. If you are working in production or somewhere that you lack control temperature and humidity, try to use carbon fiber or ceramic shafts due to their thermal properties. If possible, use the largest ball that fits your needs and the shortest shaft. It will spare you the trouble when it comes to deflection problems. Make sure you respect the recommended weight specified by the manufacturer of the measurement equipment. And last but not least, do not make very complex and complicated stylus configurations. The measurement software will have to calculate where the center of your ball is, and if you have a lot of components, this will be complicated for the software. So keep things as simple as you can. So there you have it. Hope the information received here will help you in your work as it helped me. Leave a like and subscribe for more videos from me. Stay safe and see you next time.